this big binomial problem, and I will also show you how to use the binomial PDF on your TI-84 or 83 graphing calculator. So first of all, let's read the problem. So the problem is about drinking coffee. So in a college, 80% of students drink at least 1 cup of coffee during a school day. 7 students are randomly selected from that college. Let X represents the number of students drink at least 1 cup of coffee during a school day. Complete the following distribution table. Round the probability to 4 decimal places. So first of all, how do you know that this is a binomial problem? So this is a binomial because either the student drink coffee or doesn't drink coffee. Do you drink coffee? I ask you a question. Do you drink coffee? Yes or no, right? Either you drink or you don't drink. You cannot say I drink and don't drink coffee. There is no such thing. Either you drink or you don't drink. So the probability of success is 0.80. And how many trials are there? There are 7 students, right? So n is equals to 7. So that means out of 7 students, we can have 0 students drink coffee. So that means out of 7, none of them. So 1 student, 2, 3, 4, 5, 6. The maximum is 7. All right. And then the P is equals to 0.8. So we have N, P, and X. All right. So that is enough to perform binomial distribution. So first of all, the binomial formula, what's the binomial formula? The binomial formula is you have N, which is 7, choose X, and then the probability of success raised to the X power. So I should not use X, right? I already know that the X is equal to 0. And then 1 minus 0.8. Don't write 0.2. I know that equals to 0.2. You don't need to tell me. Just write 1 minus 0.8. And then raised to 7 minus 0 power. I know that equals to 7. You don't need to show me that piece of work. Just leave that as a 0 minus 7. And then what about the calculator command? So that is a binomial PDF, and then the first argument is n, right? So that is 7, and then you have a 80% success rate, and then you have 0 success. All right, so let's do the writing first, and then I will use a calculator to calculate all the probabilities for you. So and then the next one is 7 choose 1, 0.880 raised to the first power. You can just write 0.8, 7 minus 1, and then 7 choose 2, 2, 1 minus 0.8, 7 minus 2, and then 7 choose 3, 0.8 to the third, 1 minus 0.8, 7 minus 3, and then 7 choose 4, 0.8 to the fourth, and then 1 minus 0.8, 7 minus 4. So after you write a few more lines, the formula is already in your mind. You don't need to stare at the formula for 5 minutes and then try to memorize it. 7 choose 5, that's why I make the table long. 0.8 choose to raise to the fifth, 1 minus 0.8 raised to 7 minus 5, 7 choose 6, and then 7 choose 7, right? That is 0.8 raised to the 6, and then 0.8 raised to the 7, and then 1 minus 0.8, not 0.5, 0.8 raised to 7 minus 6, and then 1 minus 0.8 raised to 7 minus 6. All right, let me double check my work. So the combination is good. The 0.8, they are all good. And then 1 minus 0.8, okay. And then the binomial, so you binomial PDF. So the next one will be 7 and then 0.8. And then you have 1 success, and then binomial PDF. You have 7 success rate is 0.8, 2 successes. So this will be 3, 4, 5, 6, 7. Let's fill in the blank. PDF, you have 7.83, so that will be 7.84, 7.85, and then 7.86, and then 7.87. So these are all binomial PDF, and then binomial PDF, and then binomial PDF. I'm not trying to make this tedious. I want you to do more writing. So after you finish one problem, you are all set for the rest of the problems. And all set means you don't need to look at your notes anymore. And then how do you get this probability? So to get this probability, there are 2 ways to do it. I will teach you both. The screenshot is on the next page of these notes. So let me move over there, and then I will show you the screenshot and the calculator at the same time. So the first one method is finding the probabilities one at a time. So one at a time, we go to second vars, and then we choose binomial PDF, not CDF, PDF. PDF is finding probability one at a time. CDF, C stands for cumulative. Cumulative means you are adding multiple probabilities at the same time. I don't prefer using CDF unless you know exactly what you are doing. So we go to second vars, and then we second vars, okay, second vars, and then the distribution DISTR. Do you see binomial PDF? In my calculator, that is line letter A, binomial PDF. So you have to press the down arrow, hit the down arrow, so that cursor will go down one step at a time until you reach to binomial PDF, and then you click enter. You click enter. So in your TI-84, the newer calculator, they will bring you to a menu, which is right here. They will bring you to this menu. All right, they will show you the trials, the P and the X, so that is the best you can get so far. But for the older calculator, like the one that I have on my screen right now, this one you have to memorize the command. The command is binomial PDF. The first thing that you have to enter is a N, and then P, and then the number of success. But in the menu, they walk you through this, and you don't need to use a comma to separate them. So since this calculator is not TI-84, so I have to input that manually. 7 and then a comma. Comma is right next to the open parenthesis, and then 0.8. Typing the 0, the last 0 is optional. And then you have 0 success, or one comma only, 0 success. So, and then you press enter, that you get a probability. So you get a probability. This is a 1.0, this is a 1.28. What is the E5? 1.28 is not a probability. The E negative 5 is times 10 to the negative 5. If you have no idea what this is, you have to use lookup resource online, and then you have to learn scientific notation. Because we will see this type of number in statistic all the time. So that means the probability is very close to 0. So this is a 1.28 times 10 to the negative 5. So that means times, no, it's not really a times, negative. That means you take 1.08 divided by 10 followed by 50. That means you move the decimal point 5 steps to the left. So that is 0.128, 128. So 1, 2, 3, 4, 5, 5 steps at a time. But I asked you to keep one decimal place, right? So I mean 4 decimal places. So if you 0.4 decimal places, that means you keep the first 4 0. And then the next one, you go back to the same place, second was binomial PDF, or you learn a shortcut for me right now. That shortcut is you type second, and then you type enter, second enter. Do you see that the previous command pops out, and then the cursor is fashioned, right? So move the cursor on the 0, just hit 1, so it will override the 0. And then you hit enter, then you get the next probability. And now you might see that the screenshot and what I am having on my calculator is different. So because the screenshot, they put it in a scientific notation. So you have to write 3.58 times 10 to the negative 4. You move the decimal point 4 steps to the left. That is 0.000358. So 1, 2, 3, 4. So if you leave 4 decimal places, then that will be 0.0004. And then second vars, you change the 1 to a 2, and then this looks like more normal, right? 0.0043. And then second vars, you change this to a 3, and then you get the next probability. Second vars, you change that to a 4, another 7, you change that to a 4, and second vars, you change that to a 5, right? And then second enter, you change that to 5 to a 6. Second enter, you change the 6 to a 7. So you get all the probabilities, and then you go back to fill out the table. And then what if I change the 7 to an 8? What does that mean? That means you ask 7 students and you want to get 8 answers. That is impossible, so the probability is 0. What if you ask 7 students and you want to get a 9 answers? That is even impossible, because you ask 7 people either yes or no, then you get 7 answers. So that's why those two probabilities are zeros. All right, so this is getting the probabilities one at a time. So if you want to, if that is the method you prefer to use, go ahead and use that. It's not hard to do, just practice a few more times. You will be good with that. The one that I like the most is doing this on the list. We are doing statistics, we are handling data, right? You need to know how to handle the list. So this is the list method. So the list method require you to enter the data first. So first you go to stat, and then you go to edit, and then you enter the number of success, the number of x, the x from 0 to 1, you have to enter that to L1. Do you see that I have some old data in here? They are from the previous problem. If you follow the lectures along, you should have the same old numbers on your calculator as well. How do you erase that? You put the cursor on top of L1, hit clear, enter. On top of L2, clear, enter. On L3, clear, enter. On L4, clear, enter. So now it's done. And then you go back to L1, you input the possible x value. So from 0 to 7, make sure you have every single entry correct. And then I am going to calculate the binomial probabilities all in one click. All right, so cursor on L2. All right, are you on L2? Not here. Not the first row. On L2, the top of L2. Right here, the top of L2. And then you go to, listen, second vars. Okay, it's not responding. That's second vars. All right, and then you select binomial PDF using the old calculator that will leave you on the list. Using a new calculator, if you're using an older calculator, look at my calculator. If you're using a TI-84 plus CEC, then you are looking at the screenshot. That brings you to a menu, right? You hit 7, and then 0.8. Here is the trick. The x value, you use L1. We are doing math in the list, so they don't accept an individual value. We are doing this for the entire list. What is L1 mean? L1 means you want to input every value in L1, every data entry in L1 to the binomial PDF command, and then you ask them to give me the probability in one click. So you will substitute each x to the binomial formula, and then you want to get all 8 probabilities in one command. So using the older calculator, you have to memorize the order, which is 7, and then comma, and then the success rate is 0.8, and then what else should I input in the next argument? That is second one, L1. I want to plug in every entry in L1 to the binomial command, and then you hit enter. So once you are ready, you hit enter, and then you see all the approximation. So the first one, they put that in scientific notation, and then the next one, they give me a decimal, and then the rest, take a look. They are all there. So you don't need to keep doing the second enter and then override the number of success. So this one gives you everything in one click. What is the benefit of doing this? What if the problem is big? X goes from 0, maybe from 0 to 19. X is big. Do you want to do that 19 or 20 times? No, you don't want to. This is a math class, a stats class. We do things in a smart way. All right, so that is the list method. And then you have to go back to fill out the table because we need those probability to answer these questions. So if you are lost, don't worry about that. Don't panic. Just rewind the video. Watch this again. Practice again. Trust me, you will get it. Okay, every time I teach this in a lecture, I make everybody get this in my class, and trust me, if you use any textbooks, open any statistic textbook, they don't explain binomial like this. They don't use a table. I didn't use the table in the past, so when students don't see a table right in front of them, they are not able to answer any probability question. Trust me, without this table, people usually miss the probability questions. So since the probability, I have the probabilities, I need to fill them up. So 0.003, I mean all 0, which is just a 0, 0.0003, and then this is 43, 0287, 0.1147, 2753, 3670, and then 0.2097. The sum is equals to 1. Sometimes if you round a lot, you round the probability a lot, maybe the sum is a little bit, just one super tiny, a little bit more than 1 or less than 1. So that is okay because you accumulate round off error. All right. But if you keep 4 digits, you should be fine. So keeping 4 digits is a very good habit when you write probabilities. So we have this, and then I need to use this table to answer all the probability questions. So what I am going to do is take the advantage of my technology, copy the table, and then I go to the probability page. I have some questions right here, and then I paste the table over, make it smaller so I can answer these probability questions. All right. Okay, the first probability. What do we have? Expected value, variance, and standard deviation. So the formulas for binomial only. Again, this formula is for binomial only. So that is n times p. So n times p, then we have then that n is 7, right? So 7 times probability of success. So expected value is equals to 5.6. So 5.6, you can round this to a 6 for your convenience. What does that mean? That means if you keep asking, you keep doing this experiment many times. Every time you do this experiment, you randomly grab 7 students in that college and then ask them, do you drink coffee? On average, if you keep doing this over and over again, you will receive 6 yes every time. Every time you grab 7 people, ask them this question, expect to get 6 yes. That's what the expected value means. And then the variance, which is MPQ. So MPQ, the Q is 1 minus probability of success. Let me just write out 1 minus P. So that is N. So that means you are taking the previous answer times the probability of failure. So that is equals to 1.12. What is the unit? The unit is student square. Variance is meaningless because the unit is being square. Student square, I don't know what it is. So standard deviation, you take the square root of 1.12. That is around 1.06. For my convenience, I will round that to a 1. So what does that mean? That means a point estimate. If you keep asking 7 students over and over again, on average, you get 6 yes. And then the best estimate, the interval estimate, is you plus or minus 1. 6 minus 1 is equals to 5. 6 plus 1 is equals to 7. That means if you keep grabbing 7 people and ask them this question, expect to get 5 to 7 yes. 5, 6, 7. These 3 numbers, they are the best guess. And that makes sense because if you look at the table, the highest probability, they are concentrated right there. So you can consider the 0.2752. The highest probability, they are concentrated around 5, 6, 7. So that's why when you give an interval estimate, the interval will land on there. All right, so that explains the first one. And then the next question, what we want to find is a non-student drink at least 1 cup of coffee. So B is the probability of none. So none in mathematics means x is equals to 0. So that means we are taking the first probability, 0.40, which is just a big 0. And then part C, find the probability that all students. So C, probability of all. How many do you have? We have 7. So all means x equals to 7. Then that is equals to 0.2097. So that is what all is. And then part D, 4 students. Part D, probability, the exactly 4. So x equals to 4. Then you got your table. 0.1147. Trust me, if I don't do this table first and just give you this probability question, you will be stuck immediately. This is based on my experience. All right. And then E and then F. Wait, hold on. D and then E, right? Haven't done E yet. At most 2. So E is at most 2. Let's switch color for the at most 2. So E is at most 2. What is at most 2? At most 2 means the maximum is equal to 2. So the less than or equal to 2, that includes 2, 1, and 0. So probability of 2, probability of 1, and then probability of 0. Overall, you have 0.0046. And then E and then F is at least 6. So F is at least 6. So at least 6 is probability that X is 6 or above. So that includes 6 and 7. Then we do 0.3670 plus 0.2097. That is equal to 0.5767. And then we have, I think we have like 2 more, right? 2 more or 1 more. That is F, and then we have G. G is less than 5. So G is less than 5. So G is probability that X is less than 5. So less than 5. Less than 5, that includes 4, 3, 2, 1, 0. What is not included? I want you to practice the complementary event. So 4, 3, 2, 1, 0. So what is not included is you don't have 5, 6, and 7. So there are 2 ways to go. Either you take 1, subtract the probability of 5, 6, 7, or you add up the other 5 probability. Let me show you both. The probability of 5 is 0.2753, and then 6 is minus 0.3670, and then minus 0.2097. So that gives you a probability, right? So that gives you less than 5. Okay, so let me quickly calculate what it is. So we have 1 minus 0.2753 minus 0.3670, and then minus 0.2097. So that is equals to 0.148. So that is using complementary event. So if you go the other way, the 4, 3, 2, 1, 0, so the probability of 4 is 0.1147, and then plus 0.0287, plus 0.0043, plus 0.0003, and then the last one is 0, and then let's add them. So this one also gives you 0.148. So I guess most people will go this way, but it doesn't matter which way you go. As long as your answer is right, you will be okay. So that is the end of this video. If you think my instruction is helpful, the method I use to explain the math is that works for you. So please tell me in the comment section below. If you like, subscribe, like, share the video out for me. I am sure that many people outside, they want this type of instruction. All right, I was signing out for now. I see you all in the next video.